This is the answer key to the Module 9.2, Day 2 on prime factorization. Find the prime factorization of 18, use the factor tree. So let's take a look at 18. We know 1 times 18 is 18, but 1 is not prime, so we're not going to use that. 2 times 9 is 18, 3 times 6. So I decided to use 3 times 6. You could use 2 times 9. It's the same thing. As long as you break it down to prime factors, you'll get the same answer. So 3 times 6 is 18. I circle 3 because it's prime. So you look at 6. 2 times 3 is 6. So now I circle 2 and 3 because they're both prime. We look at the circled factors and put them in numerical order. 2 times 3, or you could write it as 2 times 3 squared. Find the prime factorization of 20, use a ladder diagram. So I wrote 20. What prime factor can we pull out? You can't do a 4 because that's composite, but 20 divided by 2 makes 10. And then 10 could be divided by 2 or 5, but I chose 5 this time. So 10 divided by 5 is 2. Then 2 divided by 2 is 1, and I'm done because we know once the ladder diagram ends with a 1, we're done. So now look at the factors on the left, put them in numerical order, number order, 2 times 5, or 2 to the second power times 5. Find the prime factorization 27, use either method. I chose factor tree. So 3 times 9 is 27, circle 3, because it's prime. 3 times 3 is 9, circle both 3's, and that's it. So the prime factorization is 3 times 3 times 3, or 3 to the third power. Find the prime factorization of 50, use either the factor tree or the ladder diagram. So I use ladder diagram for this one. 50 could be divided by 2. 50 divided by 2 is 25. 25 divided by 5 is 5. 5 divided by 5 is 1, and I'm done. So look at the factors on the left. Write in numerical order 2 times 5 times 5, or 2 times 5 squared. Find the prime factorization of 120. Use either the factor tree or the ladder diagram. 120, I chose to do 12 times 10. You could do 6 times 20. Like you could try all different numbers, factors too. 12 and 10, they're both composite, so I keep going. 3 times 4 makes 12. I circle 3 because it's prime. 4 becomes 2 times 2, and I circle both of those because they're prime. Now look at 10. 5 times 2 is 10, and those are prime. So now I could write them in numerical order, 2 times 2 times 2 times 3 times 5, or 2 to the third power times 3 times 5. The area of the garden is 15 square feet. Shade one possible rectangle with the area. Label the dimensions, length, and width. Now, 15, those are the factors of 15, and since it's not wide enough to do 1 by 15, I chose the 3 by 5. So there's my length of 5 and then the width of 3. And make sure when you're counting, this starts at 0 and then 1, 2, 3, like that. So watch how you're writing it out. And then you can always count that there's 15 square units inside. And then go ahead and practice more problems on IXL to help you with this.